We just discussed finding the number E, and we found it by plugging in $1 compounded at 100% interest for 1 year. And we kept increasing the number of compoundings, and we approached the value of E. Simplifying the natural base expressions, E is simply a number, or Y, or a variable. You follow the same rules, so we should be familiar with the exponent rules, and they are, of course, that you take a to the n times a to the m. What do you do with the exponents when you multiply? You add, okay? You want to know these rules backwards and forwards. If you have a to the n raised to the m power, you multiply the exponent. And if you divide a to the n divided by a to the m, I know I'm just making up numbers, letters, a to the n minus n, you subtract the exponent. So you satisfy these or simplify these the same way. So this would be e to the 7th, you add. This one would be 2, e to the 1st, because you divide 10 and 5, and you subtract 2 from 3. And this one is a power of a power. It's going to be 3 to the 2nd, e to the negative 8x. And then you need to evaluate and move any negative exponent. So 3 to the 2nd is 9. It is not a negative exponent, so it should stay in the numerator. And then e to the 8x would go to the basement and become positive 8x. Evaluating natural base expressions. This is simply pushing buttons on your calculator. Let me show you which one to use. You can type it two ways. You can do second and then the division bar and then arrow up and put in the 2. So let me show you a better way. Over here on the left-hand side where the natural logarithm ln is, the base e to the x above that, you can hit second ln button and then put in the 2 because it asks for an exponent immediately. 7.389, what did it say to go to? Thousandths, okay, 7.389, and then there's that's to the thousand. E to the negative 0.06, again, just hit your second key, your ln button, and then put negative 0.06 in, and that's 0.9418. Wait, where am I supposed to go to? Okay, 0.942. Okay, go ahead and do the next one and check that you have it correct. You got it 4.953. All right, now we're going to graph a few, and I'm going to fill this in. You're capable of getting this off the table. Again, how you would type it is you'd go to your y equals, clear anything that's in there, do second, ln, and then put in x, and then we're going to see with the basic logarithmic function. I'm expecting growth, and that's because e is a number bigger than 1, okay? And it's the growth. Okay, you can go to second, graph, and get the table filled in. I'll go ahead and write them down really fast because I don't want to waste a bunch of time with copying these awful decimals. But anyway, 0.05, you can just copy what I'm writing if you like. 0.05, or you can copy the table. I'm just going to the hundredths place. 0.14, 0.37, 1. The next one is 2.72. That's actually E rounded to 2 decimal places. 7.39 and 20.09. Okay, so we can only plot a few. I'm going to plot 2, 7.39. Now, they're not going to be pretty. It's just an estimate of where these points are. I don't like my dot at all. Okay, and then I'm just going to plot a couple. 0, 1 would be a nice one to do. And 1, 2.72. And then just sketch what you saw, which it goes along the x-axis. The x-axis is an asymptote. And then up, 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 and away. This, of course, was growth. Okay, and what are you expecting for this one? You can rewrite it as y equals 1 over e to the x. And that would indicate that this is a number smaller than 1, but greater than 0, so it should be decay. Because remember, e is just a number. Okay. You can go in, of course, into your grapher. Change this to e to the negative x. And graph it. It is decay, and it's the reciprocal of the last one. So what could you do with the values you already have in the first table? Yeah, just reverse them. So in the 20.09 would be at the top, and then I'm just going to go down 7.39, 2.72, etc. It's exactly what you would see in your table. Okay, so it's coming down. You still have a y-intercept of 0, 1, but now it's negative 2, 7.39, and 0, 1, and then something else on the right. I don't care which one you want to do, but try to plot 3 points fairly accurately. And then so it runs along the y-x-axis. Okay, the next one, the 2, changes the y-intercept to 0, 2. And then it stretches the graph vertically faster. Again, if you would like, I know you can type this into the grapher and get it out of the table. So I'm going to fill the table in quick so we can get this done quickly to get on to something else. 0.21, 0.45, then 0.94, 0, 2, 4.23, 9, and 19. I don't know, they're supposed to be really close to that. But at least we got a couple of nice points. 2, 9. I can't plot 19. 1, 4 point something. Good enough. Running along the x-axis, crossing through at the y-intercept of 2, and then going up very quickly. And this is growth. Alright, now something important though about number 10 as far as shifts go. The -2 is a horizontal shift, and it shifts it right or left. Does that say plus? Okay, so it should be right 2. Now, I wouldn't worry too much about that. We'll just get some points off the table. The important one is the 1. What does a k do in these growth and decay functions? It changed something. It actually moved the asymptote, okay? It moved the asymptote to that place. So these have asymptotes. This is the asymptote with 0 here. Now it's going to be 1. You have to show that it does not cross y is 1. And this one's going to be decay because of the negative exponent. Alright, if you'd gone into your table, you would find 13.18, 8.39, etc. You may copy these in if you like. I know you can get them off a grapher. 2 is a point on the graph, and 1.61 for the last one. Alright, so 2 is the only nice one. Like the y-intercept shifted to the right. Okay, it has a new y-intercept of 3.72, which is right about there, and I don't know, 2.65. Not really a whole lot of nice points to plot. -2, 8.39. I might kind of estimate where that is, and then just sketch coming down. enough of that graphing stuff. And this was decay. So the real life application of this, in 8.1 we learned the formula for an account where the interest is compounded n times a year. This is the formula. Monthly would be an n of 12, quarterly n is 4, and daily n is 365. So if we're going to do $1,000 in an account, it would be 1 plus 7.5% would be 0.075 as a decimal, and then we'll divide by 12, and then we'll have 12. It says 1 year. 12 times 1 is the exponent then. Okay, and then all you're going to do is change the compounding number in each part. If you type this one in, we're going to get $1,077.63. Okay, I'll type in the next one. It should come down a little bit. Get out of my grapher. 1,000, parentheses, 1 plus 0.075, wasn't it? Yeah. Close the parentheses. Uh-oh, I forgot to divide. I'm doing 4, and then it'll be to the 4th power. So I got 1,070. Okay, I'll just write it down. 1,077, and the change went down to 14 cents. Okay, and then you can put in the 365. You can hit second enter, but you're going to have to insert if you're going to do that. I can change the 4 to 365, but when I back up here, I would have to delete that number and then put in 365, and then I have to close the parentheses, and then I can hit enter. Okay, got 1077.88. Alright, so the number of compoundings as they increase, the amount in your account increases. This is our new formula for instantaneously or continuous compounding. It is continuously compounding if you use E. And the formula is P, I call it PERT. Easy way to remember it. PERT. Principal times E to the RT. PERT. Okay, so I'm going to do, using the PERT, I'm going to do $1,000 times E to the 0.08. Now the exponent is the rate times the time, and that's 1 year. So we're just going to type 1,000 times E to the 0.08. $1,083.29. Oops. Okay, I can't, right? There we go. $1,083.29. All right, good enough. 800 next times E to the 0.07 times 3. What we'll calculate on the next one. And that should be giving you $986.94. Okay, try the next one, please. And check your answer when you get it. You gotta practice typing them. That just makes you remember what to do. But it does spell PERT, if you understand what I'm saying. I remember where the letters are, their exponents and what they are. Okay, are we good with $30,415.39. Okay. The next question says, since 1972, the U.S. Fish and Wildlife Service has kept a list of endangered species in the United States. For the years 1972 to 1998, the number of species on the list can be modeled by S equals 119.6 e to the lovely number, where t is the number of years since 1972. What was the number of endangered species in 1972? That would be your initial value, which would be 119.6. Now, I don't know how you have 0.6 of a species, so what would you maybe say instead? 120? Maybe, all right. But I'd take either answer. All right, this is indicating that it was 119.6. The formula is kind of ends up rounding it. Graph the model on a graphing calculator. Okay, let's see what we got. And then it's e to the lovely, quite an exponent there. 0.0917. What's at the end there? 7. Oh, and then it's the t, the x. Use x, of course, because we don't have a t. Do not try to use the t that's in there. That has a totally different meaning than x. It's in a different parameter. Okay, graph. And I won't see anything. How come? Okay, so I need to zoom 0. Okay, now it says graph it and then use the graph to estimate the number of endangered species when it will reach 1,000. So what are we going to do? Put it where? In Y2. Okay, yep, under Y2, put 1,000. Hit graph and see if you can see the intersection. Don't see it. So that means I'm going to need to try zoom fit again. And then I can tell at least this is way up there. So I'm going to adjust my window. It's not fitting for the horizontal line, so you're going to need to do an adjustment of your window. We don't care about in the past, so let's put in 0 for the years, which is your x value. And then let's go and put, like, I don't know, 40 here. See what happens for our x max. I think that's going to work. There we go. All right, so now I'm going to go, it's looking like maybe about halfway, so probably about 21, 22 years. Let's see. Second trace. Calculate the intersection, 5, enter, enter, enter. Yep, 23 years, 23.16 years. Now, is that the answer, though? It says use the graph to estimate when. Would you say 23.6 years? Would anybody know when you meant? No, when did this thing start? Okay, 1972. So if you add 23.16 years, which is kind of strange, but what is that? 1995.16. Okay, so that would be your answer in what year it would happen. So that happened a long time ago based on that model. I do not know what it is now. It would be interesting to see. Okay, and what's the horizontal asymptote for the graph of this on 16? All right, so y equals -2. Yep, would be your horizontal asymptote. Okay, I'm not going to do the Mizheimer problem right now necessarily, but it does, well, it says, because I think I'm running out of time on my recording, but if she's investing $10,000 and she has it at one bank, she'll get an interest rate of 4.2% compounded quarterly. That would